Hello students, welcome back to video whisking. This is video 7.1, circular art and spirals. That's right, that's what it's called. And the objective today is I can identify and use radii, diameters, chords, secants, and tangents. Okay, so the Excel skills you want to focus on are U1 and U7. And let's go, flippers. So the first thing we want to talk about is let's welcome again to the study of circles. Two cool pictures for you to kind of think about why I put them here. Okay, and let's start with some circle terminology. So the first circle word that we need to understand is, hey, what a circle actually is. So a circle is, and you're writing this as a definition, a circle is a locus of points equidistant from a point called the center. And circles are named by their center. So if I were to think about a circle, and here's a circle over here, the center of this circle is actually M. See it right there, it's M. So this circle is going to be named circle M. And we actually do this. We'd make a circle, put a little dot in it, and then we put M. So the second word that we want to talk about, let's check off that first one, is going to be radius. So a radius is going to be any segment with endpoints at the center and a point on the circle. So if we look again at our circle M, we can find many radii. Radii is the plural of radius. So let's name them. So we can actually name radius AM here. We also have radius DM, radius RM, and radius IM. And remember, you can actually write these the other way because of the symmetric property. We can actually just flip it around. Okay? And you want to actually make sure you jot those down. Let's go on to a chord. A chord is kind of cool. This is probably a new word for some of you. Okay? A chord is any segment with endpoints on the circle. Any segment with endpoints on the circle. So if we look at the picture, I'm going to say if I can find segments with endpoints on the circle. And here's one, US. US is definitely going to be a chord. So that's also a segment though, so we're going to say US. And we're looking for any others. And if you look at the picture carefully, there is another, and this one is actually RI. Now RI is a special kind of chord, but let's write that first. Now the other special chord, which is RI, is actually a diameter. And I want you to add this to your definitions. A diameter is a chord that passes through the center. And if we look clearly here, RI is a chord, but it actually has point M on that line, so that makes it also a diameter. So I'm going to write here, that will be RI. All right, so we've taken care of circle, radius, diameter, and chord. Now for the final two, and these are kind of fun, okay? A secant. A secant is going to be a line that intersects a circle in exactly 2 points. Exactly 2 points. The difference between the previous ones that we've seen, and that would be radius and chord and even diameter, is that these were all segments, whereas a secant is going to be a line. This is going to be specifically a line. If we look at our picture and we're looking for a line, we can clearly see that line NT is going through the circle and touching 2 points on the circle. So let's write that down. Make sure that you write it as a line. It's got arrows on the end because it keeps going in both directions. And finally, last but not least, we have tangent. Okay, so a tangent is a line that intersects the circle in exactly 1 point, just one. It does not touch anywhere else other than that 1 point. So if we look at our picture, we can clearly see here that this line here, and that would be line RK, actually is a tangent line. So let's actually write that down. Careful here, I'm going to draw a blue arrow down. That would indicate we've got line RK. And there's something very cool about tangents, which I want to make note of right now. Tangent lines give us something called right angles. And where we have right angles, we can use the Pythagorean theorem. So if we look at our picture to the right, and we look at the tangent line here, so I'm actually going to go over it in blue. There's our tangent line. It's intersecting the circle at just one point. At one point. Now, if I were to look at the radius RM, there is going to be a 90-degree angle formed here. That's automatically because of the tangent line. Let's just add that in, that the tangent line forms a 90-degree angle with the radius, and this is going to be an important feature later as we move on. All right, so let's look at our examples here. The first one says, name all the parts of this circle. So here we go. There we have it. We have circle E with the center point at E. We've got radii AE, RE, GE, and TE, which are all line segments. We've got chord TR, and it's also a diameter TR. Question number 2 says, if segment PM is tangent to circle L at M, what is the length of LM? If this is tangent here, PM, then we know that there's a right angle in this corner. We can now use the Pythagorean theorem. We use the Pythagorean theorem here and substitute in A and B. We're going to get A equals 7, and that is our length. So that would be the length of all the radii. If I drew in more, this one would also be 7. So would this one, etc. So number 3 is a question that I wanted you to see, but it's asked in a different way. It's very similar to question number 2. It says, well, is ML tangent to N at L? Explain. Well, we've got these 3 measurements, and they're saying that we have ML, and we want to know if it's tangent to L at N, circle N. So let's see. That would mean that there would have to be a right angle here in this corner. And that would mean that this would have to be a leg, the 7 and 24 would have to be a leg, which means that 7 squared plus 24 squared would have to equal 25 squared. And we just proved this the other way. Now we can go ahead and substitute in, and we can see that this is a true statement. So yes. And our reasoning is because we were able to prove using the Pythagorean theorem this must be a right angle, and there must be a tangent line there. Okay, I apologize for my silence today. It is very, very wiggly. Here's your secret hot question. It says, segment RT is tangent to circle Q at T. So there's T up there. It says, can you find X? Can you find X? So there's R, there's T, find X. Remember to work on your Excel skills, U1 and U7. Later, dudes.